By the early 1970s, McDonnell Douglas faced a problem it couldn't ignore. The DC-9 had served the company well since its first flight in 1965, becoming a reliable short-haul jet for airlines around the world. More than 900 had been sold, but the aircraft was beginning to show its age. New competitors were entering the field. Boeing's 737, introduced in 1967, was steadily gaining market share, and European manufacturers were preparing something even more advanced, the Airbus A320, a fly-by-wire twin jet that promised lower operating costs and higher efficiency. The landscape of aviation was shifting fast. The 1973 oil crisis sent fuel prices soaring, forcing airlines to cut costs wherever possible. Older jets like the DC-9, optimized for shorter routes and lower altitudes, were becoming expensive to operate. Airlines began asking for aircraft that could carry more passengers, fly farther, and burn less fuel. McDonnell Douglas couldn't afford to design an entirely new airplane, not after the massive financial strain of developing the DC-10, which had entered service in 1971. The company's resources were stretched thin, and internal memos from the period reveal a growing concern that without a quick response, the company could lose its grip on the narrow-body market entirely. So in 1975, engineers in Long Beach, California, began exploring an alternative. Instead of building something from the ground up, they would evolve what they already had. The DC-9 would be stretched, its wings enlarged, and its engines replaced with a new generation of high-bypass turbofans from Pratt & Whitney. This strategy, later called derivative design, allowed McDonnell Douglas to save time and cost, producing a jet that could appear modern without the years of risk tied to a clean sheet design. Internally, the plan was known as the DC-9-80 project. The goal was clear: extend the range by at least 15%, improve fuel efficiency by 20%, and increase passenger capacity from 100 to more than 150 seats. If done right, it could compete directly with Boeing's 727-200 and offer a cheaper alternative to the upcoming 737-300. When the DC-9 Super 80 program matured into the production-ready MD-80, McDonnell Douglas was betting on a careful mix of proven systems and incremental innovation. The design phase wrapped up in 1978, with the company committing to the new JT8D-200 engine line from Pratt & Whitney, producing up to 21,000 pounds of thrust, roughly 15% more than earlier DC-9 models. This new engine not only provided greater efficiency, but also complied with the first generation of international Stage 3 noise restrictions, a growing concern among regulators and airport authorities by the late 1970s. Engineers also stretched the fuselage to 147 feet, redesigned the wingtips with strengthened spars for heavier fuel loads, and improved the cockpit with a semi-glass layout that retained analog reliability but introduced modernized avionics integration. The prototype, registered N1002G, completed its maiden flight on October 18, 1979, from Long Beach, California, under the command of Chief Test Pilot Ed Greathouse. Over the next 10 months, the test fleet accumulated more than 1,000 flight hours to achieve FAA certification on August 25, 1980. The first production delivery went to Swissair on September 13, 1980, which inaugurated passenger service from Zurich to London Heathrow less than a month later on October 10. Austrian Airlines quickly followed, integrating the type into its European network. By 1981, McDonnell Douglas expanded the line into multiple variants to suit different airline requirements. The MD-82 debuted with Republic Airlines in August 1981, optimized for higher payloads and hotter climates. The MD-83 followed in 1985 with extended range tanks and uprated engines, allowing carriers like Alaska Airlines to link destinations across North America without refueling. In 1987, the shorter-bodied MD-87 entered service with Austrian Airlines, tailored for airports with shorter runways, while the MD-88, certified in 1988 for Delta Airlines, featured a fully digital cockpit and improved cabin soundproofing,
marking the final iteration of the family. Each variant reflected a specific operational niche: short-field capability, long-range performance, or reduced cockpit workload. By the late 1980s, production at the Long Beach plant reached a peak output of 12 aircraft per month, serving an expanding global clientele from TWA and American Airlines in the United States to SAS, Finnair, and JAL abroad.
By the early 1990s, McDonnell Douglas engineers were already looking for ways to extend the life of the MD-80 family. The goal was simple: reduce noise, improve fuel burn, and modernize the power plant without designing an entirely new airframe. In 1993, Pratt & Whitney proposed an advanced derivative of the JT8D engine, incorporating a larger low-pressure compressor, an extended exhaust cone, and a refined annular burner system for cleaner, quieter combustion. The engine also featured a redesigned low-pressure turbine and mixer section, along with an increased fan diameter by precisely 1.7 inches to improve overall airflow and efficiency. The projected thrust output was around 21,700 pounds-force, or 97 kilonewtons, which would have given future MD-80 models shorter takeoff distances and improved climb rates, particularly on hot and high routes. McDonnell Douglas considered offering this new power plant on late-build MD-88s and even evaluated the aerodynamic benefits of fitting blended winglets inspired by ongoing tests on the MD-11 widebody. Engineers at the Long Beach facility modeled several winglet shapes, noting that even a small improvement of 3 to 5% in fuel efficiency could extend the aircraft's range by over 150 nautical miles. Despite the technical promise, neither the winglet modification nor the JT8D upgrade went into production. The global airline market was shifting rapidly. By mid-1994, the launch decision for the upgraded engine was quietly shelved as McDonnell Douglas shifted resources to the next evolution of the family, the MD-90. The MD-90 program officially began in 1989, taking the MD-88 structure and stretching it by 5 feet, 1.5 meters. It introduced the IAE V2500 high-bypass turbofan engine, a major leap forward in both fuel economy and noise reduction. The MD-90 could carry 172 passengers farther and quieter than any of its predecessors. Its cockpit featured a full electronic flight instrument system, or EFIS, replacing analog gauges with early digital displays, a nod to the growing popularity of glass cockpits pioneered by Boeing and Airbus. The prototype took its first flight on February 22, 1993, and certification followed 2 years later. Launch customer Delta Air Lines introduced it into service in 1995, ultimately operating one of the world's largest MD-90 fleets until its final retirement flight on June 2, 2020. In parallel, McDonnell Douglas pursued a smaller next-generation design meant to replace aging DC-9-30s still in operation. Designated MD-95, this aircraft reimagined the original DC-9's short-haul mission with modern systems and new Rolls-Royce BR715 engines. The MD-95 retained the 5-abreast seating but featured a completely redesigned flight deck and new manufacturing processes to reduce maintenance downtime. Its development began in 1991 with the first flight on September 2, 1998, and entry into service with AirTran Airways in 1999. But before the MD-95 could truly take off, McDonnell Douglas was absorbed by Boeing in 1997. The newly merged company rebranded the MD-95 as the Boeing 717, positioning it as a direct competitor to the Airbus A318. Ironically, what began as a late-stage DC-9 redesign under Douglas ended its life under Boeing's badge, closing the book on over 3 decades of continuous development that began in 1965. By the 2010s, the MD-80 had found a second life, not as a passenger jet, but as a workhorse for specialized operations. In February 2013, Commercial Jet Inc. delivered the first converted MD-82 SF freighter to Everts Air Cargo, marking the start of the Aeronautical Engineers Inc. passenger-to-freighter conversion program. Just 6 months later, USA Jet Airlines became the first operator of the MD-88 SF, acquiring 15 retired Delta Airlines aircraft, 6 for conversion and 9 for spares. The conversion transformed the jet's cabin into a dedicated cargo deck with hydraulically operated doors, reinforced flooring, and aluminum window plugs to reduce weight. Each MD-80 SF could carry up to 12 88 by 108-inch pallets, offering a low-cost alternative to larger freighters.
By 2021, AEI had delivered 21 MD-80SF conversions, with more in progress, and most of these aircraft were operating across North America. They carried automotive components from Ford and General Motors from Mexico to the U.S., and also served in Alaska, hauling fish, mail, and supplies to remote regions. The MD-80SF's biggest advantage was its low deck height, which allowed ground crews to load it directly from pickup trucks, something impossible with taller cargo jets like the 757. Its narrow fuselage, however, prevented the use of standard A containers, limiting it to smaller, non-standard cargo pallets. In July 2022, Everett Air Cargo selected Universal Avionics, an Elbit Systems subsidiary, to retrofit its MD-80SF fleet with upgraded flight management systems, LPV-capable GPS, and new integrated avionics, extending the type's operational life and improving safety in remote conditions. These upgrades kept the freighter versions relevant for charter and mail transport across the U.S., Canada, Mexico, and the Caribbean. Meanwhile, another branch of the MD-80 family took on a very different mission: firefighting. Starting in 2013, Ericsson Aerotanker converted 5 former Scandinavian Airlines MD-87s into aerial tankers. Certified by the FAA in 2014, these aircraft were modified with external ventral tanks and could carry up to 4,000 gallons of fire retardant, nearly double the load of older Lockheed P-2 Neptune tankers. Despite carrying less than the massive 747 Global supertanker, the MD-87 offered a unique advantage. It could operate from shorter, more rugged airstrips, ideal for wildfire-prone regions in the western United States. By 2024, Ericsson operated 7 MD-87 air tankers under contract with the U.S. Forest Service and CAL FIRE. Each aircraft could be loaded through dual 3-inch ports, filling a full load in under 7 minutes. Pilots often flew with the landing gear down during retardant drops, using the drag to stabilize speed and reduce engine lag on climb-out, a technique borrowed from classic Douglas tankers like the DC-7. These conversions extended the legacy of the MD-80 family far beyond its passenger service years. Whether hauling auto parts, mail, or fire retardant, the aircraft's rugged design, low operating cost, and proven reliability ensured its place in aviation long after its last commercial flight. Across nearly 5 decades in service, the MD-80 series saw its share of close calls, many of which showed just how tough the jet really was. In 1988, American Airlines Flight 132 made an emergency landing after a cargo fire. Everyone survived. In 1991, SAS Flight 751 lost both engines after ingesting ice and crash-landed in a snowy field. Miraculously, all 129 aboard lived. Runway overruns were a recurring theme. Korean Air Flight 1533 overshot the runway in 1999, and Delta Flight 554 and 1086 in 1996 and 2015, respectively, both skidded off at LaGuardia in icy weather. Later, Ameristar Flight 9363 overran in 2017 due to a jammed elevator, and Red Air Flight 2032 suffered a gear collapse in Miami. Even into the 2020s, incidents continued, like Caspian Airlines Flight 6936's overrun in Iran and African Express Airways' 2024 runway accident in South Sudan. Yet, despite dozens of accidents, the MD-80 family maintained a remarkably high survival rate, a testament to its solid Douglas engineering.